All right, so okay, so this is lecture number 15. As again, the number 15 means this is week number 8. That's all. Doesn't mean that you have all the lectures posted because there are some days are holidays. So there was no lecture, so that means that number doesn't post. Let me just quickly, just to reiterate, this is week number 8, and we are going to discuss today solid and hazardous waste management. And what we cover this week is a very brief summary of what you are going to cover in CE164, which is the class that many of you registered next for the next quarter. That name is Sustainable Waste Management. That's the new name of the CE164. And then we will talk about air pollutions on week 9. And then week 10 is mostly resource recovery or sustainability aspect of this class. Um, Again, as you notice, week 8 and 9, 10, these are all not related to water. Most of things, everything related to water has been covered. Wastewater is the last class. Today is all about solid. I mean, there is some water. If groundwater is polluted, then obviously it's a war. But it's kind of a waste management, different kind of techniques. Then air pollutions, that's all about air as the name signifies. Week 10 is about materials and energy sustainability. Okay, so those will be how you can, how whatever you learn, how you apply that for different sustainable problem, engineering problems or challenges. The long questions will be in the finals. You have 3 long questions. One is from wastewater, so that's one question. Second is on hazardous or solid waste management, and 3 is air pollutions. And these are all mass balance. Okay, because there are no concept, new concept. These are all mass balance questions. And then short question will be everything within these topics. But there are some questions like BOD. BOD is covered here, so that means you should be able to answer those questions. So anything that covered in this weeks, the concept will be also part of the finals, even though they are covered before. Okay. So if you do not understand those concepts, it's good time to also go back and check those. Again, announcement: homework 6 is released today. It will be due next week on Monday. There will be lots of example questions on those homework that will be recorded in, or I'll post that one by end of today, so that you have at least some help for start answering those questions. And there are 4 questions. I'll show it here. And there is less amount of discussion session because of our Thanksgiving break. And TA also have their break, so that means you have relatively less interaction through TA this time for this homework. But having said that, no, you should ask any questions on by email. And on Monday we'll have a office hour next Monday, and when before it's due. So any last moment helps, we can help you on that day. Um, I might actually extend this one because of that. Let's say this is a Tuesday. That way you have a little bit at least extra time if you don't. Let's see, is that November? That November 30 will be December 1 probably after that. Okay. Just because you have some extra time. I mean, I understand that this is Thanksgiving week, so you might be spending a lot of time in with family or talking with friends. I don't mean to endorse that you should visit your family. Um, I mean, because of COVID, that's something we should be all be careful. What I mean is, um, you'll be spending a lot of time buying different stuffs like I do, check online, all these good deals. So those will be time off from the homework. Okay, so there is no office hour this week. The reading assignment for this class loosely based on the sections. Actually, this is section 7. On chapter 6, I upload those materials. But most of the materials that is in the textbook is not as extensive as I posted here on the lecture. So if you have any questions, you could obviously ask. So this is homework number 6. Okay. So as you see, these two questions are from textbook exercise questions, but there are other two questions which are related to wastewater mass balance. The reason I gave this question is because final questions are very much similar to mass balance concept. So it usually gives a figure. So now for many questions that you will solve, there is no new concept. It's basically you are adding all them together to solve a larger questions. Like a full, for instance, there is a wastewater treatment, then it goes to river. So that means now you have to integrate all the different factors. So those questions are question 3 and 4 are mass balance, but related to wastewater. Okay, so the concept is still wastewater, primary, secondary, all that. So it will give you some practice for how to apply every concept you have learned in the larger, bigger problems, or not bigger in the sense of whole holistic problem. I'll solve many questions, similar question to here, so that you have some exercise or experience in solving this. So, all right. So let's see. Midterms. No, midterms. I have not graded yet because I didn't post the solutions to TAs. I will also grade some of the questions. TA will help me grade some other questions. Again, like homework, you should check your solutions and see if unfairly if you get any points off. You have until end of final to ask for any regret if you have by mistakenly if we change any grades. So again, check back your homework grades as well as midterms grade once it's released. You should always check, if just in case there is some issues or error. Some lesson I learned that is which I didn't anticipate, even though it was 24 hours window, a little bit more 24-hour windows. Some students start answering questions at midnight, so then they post questions which I happened to be awake that time, but doesn't mean that I was anticipating all that. So it was like I could not work anything else during that time, and I didn't also want you guys to feel left out, so I ended up answering. And I realized that's not going to be feasible for finals because I don't want to commit for 24 hours me being available to answer any questions during exam. So what we'll do is we'll have a 3 to 5 hour answering windows. That means I'm any question asked during that time, which is basically that time is already assigned for your final from the starting of this quarter. So majority of the students I recommend take exam during that time. That way, if you have any question, I'll answer. Unless there is really very critical questions, I will try not to answer. The reason is it's everything posted already on Slack, not Slack, Campusware. So many times I see students not even reading those and ask questions again and again. So something we learn, obviously none of us anticipate that. So these are some changes I will implement on the finals, like 4 to 5 hours of time where you can ask any question. Hopefully you'll take that exam during that time. Um, no, you can take test any other time, 24 hours window, but within that assigned window of this like Friday certain time, if you take the exams, you'll know if any question you have, I can answer. You can take within 24 hours, but I will not answer every question if you post. I'm not obligated to answers. The reason is, as I said, I rather have 3 to 5 hours of proctoring than whole 24 hours. Obviously, TA can respond. I'll tell them to keep an eye to help me out. This time they could not. Very small percent of the class ran out of time uploading the grade in Gradescope. This is one issue that something I have to also deal with. Is the reason is when we have open book exam, the time management is a lot of time related to how efficient you are. As I said, a lot of times I don't consider that you have to have final answer. You can set it up every questions and write the equations, write all the values correctly, and don't calculate. You still get full points. So these are something you got to learn how to do efficiently if you have to manage within 4 hours. But 19, I would say that except these are like 10 people or 10 or 12 people have 10x, around 10 people. So that's a very small percentage of the class who had difficulty at the end. They ran out of for a minute or two. Just be aware of this one. So what I recommend is in the finals, don't write the final answer if you feel like you're not going to finish it. Just set it up the questions, put the values, and then just not use the calculator anymore. Just say that this is the answer and this will be this unit, and you are fine. By for correct step, you'll get full points. And second thing is, you should start uploading whatever you have. Scan it, upload it 10 minutes before, so that start that process. And only when you finish, then if you have some time remaining, then only you can work on the rest of this. That way, for sure you'll be able to upload everything on time. Again, final, we talk about last 5 weeks of class, which is this will be part of the finals. These are the four different three long questions: waste treatment, waste management, air pollution, sustainability. That's the last week. There will be probably one questions from that. That's the final week. It's not that important. So obviously these are the most important part you want to learn. And but again, this is same format as midterms. The one key understanding is these are all mass balance questions. Okay, because we are talking about wastewater treatments or waste management or air pollutions. You're not learning new concept. You are just applying same thing over and over for a different type of problem, which is more like a holistic problem. Means there is a source, there is a mediums, and then there is a exposure. So that means you will understand how to apply this concept to solve more or the problems which are related to kind of cross not just one chapter, multiple chapters. Again, this week, what we are going to learn today is CE164. That's just a snippet of what we are going to learn in this next class that I'm teaching on every winter. The name is Sustainable Waste Management. I just learned today that it was full. So I asked the department to increase to 60 so that many of you can register. Again, this is a prerequisite is 153. So that means everybody who attend this class are already qualified to take that class. The biggest difference is that class is a project-based learning. That means you are going to write a project as a group. So group will be 4 to 6 persons, not four, around 5, 6 to maximum 6 person. And then you'll also present to the class at end of the quarter. So you learn about how to design a project, how to write about it. So there is no finals. So it's everything like this class until midterms. After that, it's all kind of writing projects together with students. But you'll have class every week, as usual. So again, if you need PT, send me email. As far as I remember, I responded to everybody who asked for PT. This is required if you are not civil engineering students. If you are from different departments, I have to give you PT to register. So if you need that, send me email. And so either send me email or on campus wire, just send me a message. I'll post the PT. And that course detail, again, just to give you a perspective, there will be homeworks, 10% quiz. Because there are no finals, there are smaller quiz. Okay, so that's the 20%. Midterms and final project is 35%. And so this is team effort. This is individual. And like any other, so there are this is not the only class I'll teach. There is another class called Green Infrastructures where you learn about stormwater management. The format is very similar in the sense that you'll learn how to write well in this class, write scientific reports. So that's something. A lot of time you when you go for interview, it helps. If they ask you, if you have any experience in working on a project, you may not have direct experience to work, but you can say that no, I didn't have direct experience, but I took this class where we designed these conceptual projects related to solutions, either remediations or water treatments or water management. So those are kind of helpful to discuss about those during interview. So these are the things I heard that a lot of students get benefit from that. So that's the highlight of this class. These two classes. Again, the course title is first 5 weeks. Mostly you learn about remediations of hazardous waste. Then next 2-3 weeks you'll learn about management of municipal waste, which is non-hazardous. And then you at the end you talk about technology to recover resource, which is basically similar to what's the last class of this quarter. Um, so that's all for the CEE154. But now, waste management. Waste management, the learning objective of today's class. When you think of waste, it could be solid or it could be liquid. And when we say waste management, think of this one. We already start doing waste management when we think of wastewater, because it's kind of a waste. So this is wastewater treatment plant, um, and there are two kind of waste here. First is it's coming in as wastewater, so we are dealing with that one. But it actually create another waste. That's let's say sludge or biosolid. I'm just going to write it clearly. Okay, or biosolid. The reason they apply biosolid, so that solids sludge sounds brush. A lot of times people think this is bad, but it's a valuable resource. It has lots of nutrients, so we call that biosolid. It's applied as a fertilizers, particularly wastewater treatment plants, domestic wastewater treatment plants, or municipal wastewater treatment plants. If it is industrial, then there are a lot of pollutant. You may not apply the solids. But so these are the waste. These are solid waste. How to manage it? Where to use it? Is this hazardous? If it is hazardous, how to make it non-hazardous? For instance, this wastewater biosolid will have lots of pathogen. So how do you destroy that? How to remove those pathogens so that it become non-hazardous and become useful? So these are the concept you learn in the this class, or also in the class that I teach. So today particularly we'll learn about environmental laws that enforce how to manage waste, not just hazardous waste, non-hazardous waste too, hazardous and non-hazardous. I'm just going to write here non. Um, you learn about how to assess a site if it is polluted. You'll also learn about how to predict the fate based on contaminant properties, and predict transport in groundwater. So as you see, this is actually your groundwater question. So this is not a new question. We'll just revisit the same thing. There's no new concept. The only difference is there is a source here. You already start applying this concept in your in previous midterm. So this is kind of revisit again, and then you will learn about treatment technology. So this is mostly today's class, very little today class, but no, next class will be all treatment technologies. Today is more about the concept as well as something that you learned before. Okay, sustainable waste management. Just to revisit again, why we are doing sustainable waste management. Think of big cities, because that's where the most waste are being created, because 70% people are living right now in US in big cities. So big cities require lots of resources because a lot of people live there. When we think of resources, the water, materials as well as energy. Okay, so let's say something that we don't really write always. Um, but energy production actually requires materials as well as water. And so you use those energy, and then you have also waste. And those waste are wastewater and solid waste. Mostly solid waste goes to landfill, and wastewater goes to, if you are in um, ocean or surface water. Okay, so you discharge those after treatments or after managing it certain way. So that's not sustainable. So you got to, because there is uh, whatever resource we have on Earth, we cannot use them like this forever. We run out of it at some point. So that's why you have to recycle or reuse some of the concepts. So that means you have to learn how to treat them. So that's what you're going to learn in this class, is how to treat something which you already polluted. And mostly this is based on soil and water. We're not dealing with materials. We are also not going to deal with energy, because that's something the last class. Last class we learned about energy management. So when we think of hazardous waste or solid waste management, think of materials or water. And so why we need this one? If you think of this YouTube video, if you watch this one, this video is all about why EPA was formed. Because there are a lot of times, people dump their waste on river surface water without any treatments, because there was no law that forced them to do it. So they have been dumping all the wastewater and any kind of solid debris. Imagine you have a house and you destroy the house because you want to rebuild it. All these debris you form, you just throw into a river. And any kind of trash, you don't have to have throw a trash, you just throw into river. That's what we do. They used to do. So now these waste and all that are basically BOD or COD, so oxygen demand. So that means if there is a fire, there are lots of fuel. So that's why a lot of time the river catches fire because of this reason, because there are lots of debris. It's not like river water is on fire. Everything stops inside water is on fire. Um, so that's why one of the reason why these laws came into place. So, and you can also think of another other aspect of pollutants which you don't see, which is below ground, and groundwater pollutions. And groundwater contamination is a big issue, because people can dump their waste underground without really nobody knowing, and then eventually that pollutions spread across the environments, and people drink that water and they get sick, people die. That's the story. And so if you watch this movie, particularly Civil Actions, this is all about how these particular lawyers unravel these stories, chemical company, how they dump all these things into, and trying to get away from it. So I should watch it. I particularly didn't like at the end, because obviously the ending was not great. But that's the whole thing. Many of the environmental stories are um, basically, not necessarily great stories. That's why there are a lot of work to be done. So again, we'll learn about hazardous waste based on these two overall concept. And as you think, a lot of times we either deal with a water, contaminated water, or contaminated soil. And contaminated soil also equate to contaminated groundwater. So that means you have to remediate that groundwater. And there are lots of remediation technology. If you see that evolve over time, in in 1970s, they are all discovering different type of contaminations. And they realized that their action was the reason why these wasters around. That's why the regulation started in 1970s when there was EPA. 79 EPA was formed. So after that there is regulations. Because of regulations, they have to start treating it. So the first thing, they don't know how to treat. So they just, their first goal was just to excavate, remove the source, and then just get rid of that way. That's too expensive, because if you have an entire ground polluted, you can't dig entire ground, because it's just so expensive. So people start learning how to actually remediate at the site itself without removing the pollutant. So the in situ remediation came into play in 1990s. And that time, in situ remediation means, think of either pumping the water and then remediate it, or just apply some kind of biological stuffs to start remediating. But it was not very well developed that time. So over time, people learn more about it. So bioremediation start coming in 2000 around those time, because bioremediation that time initially people thought is very slow. They wanted faster results. But then they realized any chemical based treatment is not efficient. It takes so much energy and materials. Bioremediation is pretty least expensive among all of them, and also more sustainable. So sometimes you have to think of, do you have enough time? If you have, you should go for bioremediations if possible. If not, then you have to have combination of that. But in 2000, during that time, people start learning about sustainable way. Means green remediations means you have to use some materials that is cheaper, that is also effective, that's not also causing more harm. So when you think of green remediation, it means you apply energy or apply chemicals, those do not cause any extra harm. For instance, many of the previous technology where you apply some kind of chemicals to destroy one chemical, then you produce something else that become a pollutions. So now green remediation means you're not having any extra pollutions, and then you have other things that going on now. So things are improving, going more towards sustainable approach. So we learned that some concept in the last class. So again, overall goal is about any remediations. Your traditional approach may not require, you know, to lower the cost, and you lower the cost by using some kind of sustainable angles. For instance, you lower the material cost, you lower the need of time, all those factors. So that's the all method come into this play. That's what sustainability means. It's not just a material side, it's also economy side. Because if it is too expensive, nobody is going to implement it. Any question? Let me see the chart window just in case.
So remediation, you said that it's the economic side as well as uh the benefits that it brings.
Yes, yes. I think the economy is the first one. It doesn't mean, so what I mean is your your solution cannot be so expensive that exceed the property value. Okay. So a lot of times, a lot of places, there is no remediation, not because there is no technology, is because there is no feasible way to do it, by keeping the cost within the value of the property. It's like your car, if you can fix it certain time and then drive it, that's fine, you fix it. But if you have to pay more and then you can't sell that within the same price, then you rather buy a different car. So that's exactly same concept here. Remediation has to be feasible. There are some questions on the chat window. Let's see if we. No, there is nothing about what we cover just now. Okay, so environmental laws. Again, as I said, nobody would respond to any kind of environmental disaster unless there is a regulations. Without regulation, everybody will pollute, and that's how has been the case all over. Because we are human, we take the easiest route. So that's why these laws are important, and it's important that you recognize those laws. And so there are many laws, okay, but these are the five or six, let's say how many, seven laws that you have to think of. So we'll learn what those are and what that means, why it is relevant, and mostly I would say that these are the key laws. Okay, CERCLA. Okay, so these are the four key laws that you got to be aware of. Everything else is a very kind of subset of those. Okay, so let's think of what that means now. First one is Solid Waste Disposal Act. Again, as I said, all the river were catching fire. There was no regulations. So how do you prevent people? all this dumping all these waste into it. So that's why the act came in, that Solid Waste Disposal Act. What it means that you have to minimize your waste. You have There is a limit how much you can dispose, and you should find a way to not dispose everywhere. You should dispose to landfill. That's all it means. So it says that don't dispose in a river or surface water where people use it. Dispose into landfill. Okay. So that's the idea, that you have to manage the waste. It doesn't say anything about reductions. So what it does, it again, it says what it has to enforce the law. So that means now this municipal agency or industry, they cannot dispose all their waste into a river, nearest river. They have to dump into somewhere else. So it does minimize the waste into the surface water. But what it doesn't do is now people realize that it's not so it's not very effective. The reason is there is going to be a lot of landfill. People just dump everything into landfill because it's cheap. There are new business, but that doesn't solve the problem. You run out of space for landfill. So that's not the original intention. Your intention was people minimize waste. So that's why the next law, they say resource recovery. They don't write about waste. As you see, this has waste. Because of waste, people thought this is a waste, so just waste it. What's the goal of waste? Just wasting it. And so that's why they changed it. They said, no, 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 this is not waste. This is a resource. So you should recover it. You should not just dump it out. No, you should find a way to use it if you can. So that's why they call Resource Conservation and Recovery Act. That means you should recover some of the materials if you can. Only when there is no other things to do, then you can make them as a waste and dispose it. So that's how, and they also define what kind of waste they are, which one is hazardous waste, which are not, all those factors. So again, what they did is they talk about, um, and they talk about also not just waste we created, also in the entire process, not just the person who created those material, but also person who receive those materials, who use those material. Everybody else are supposed to manage it. So it clearly defines the waste types. It says which are hazardous, which are not. It also requires the generators of hazardous waste to final reports. That way people know. It also state gets the authority to develop their own hazardous waste program, because uh, federal government did not have that capacity to manage it. So that's why they give more authority to not just EPA, they also goes to the state. So that means every state can say this is not hazardous. So any state, that's why in California there are some laws which are very not extreme, which is very more much environmental friendly than if you go to, let's say, another state which doesn't have any good environmental programs. So that's why you see there is a clear distinction because of this law, because each state has their own way to design it. But federal government will just impose what could constitute hazardous waste. They will just provide a guidelines, but the state has to say what limit it should be. Again, the limitation, it regulates the generators. It doesn't regulate anybody who transport it. For instance, let's say the chemical company, they create the chemicals and they say, okay, I'm managing all the chemical produced in my facilities. Then they sell those chemicals to, let's say, somebody end users, and the truck companies, they carry those chemicals. For instance, the chemical might spill. The trunk company might have managed it properly. So it doesn't do anything about those. It just regulate mostly generator, not anybody else who handle the waste. So that means you are not really minimizing those pollutions if you are not looking at everything else. So that's why the next one is a liable work, so which is the, where is that, 1980s, because if you see this is the next one is 1984, so that's why I jumped to 1981. Okay, so 1980 Act, what they do is that Comprehensive Environmental Response and Compensation and Liability Act. What that means is that now everybody is liable, not just person who is generating, also produce person who is transporting, and also the person who is using it. So nobody can say that just because I'm not the producer, I should not be liable. So that means the petroleum companies are liable as much as the trans person who or the truck company who transport those petroleum, as much as the gas stations who distribute it. So that's why these laws was important. And not only that, it gives a very it gives a mechanism to actually treat some pollutant contaminated site. Because as you see in this here, there are many dots. As you see, these are highly polluted site. So these sites are polluted by somebody else. They are move on. So sometimes those sites are abandoned, and there is not enough money by those company, because if they declare bankruptcy, there is no way to treat it. And then what will happen? The public has to somehow live with that. So that's why there is not they have to produce some money. So federal governments impose this tax. If you every time you buy gasoline, you pay some tax, and that tax goes to here, CERCLA. So they develop this mechanism to collect taxes, so that all these abandoned site can be treated by federal governments. So they have this money resource now because of this particular act. Um, so that what it does, the biggest advantage of this act was that everybody is liable. So nobody can say, just because I have this property 20 years ago I sold to somebody else, I'm washing up my hand. That doesn't happen now. That means you are also liable. You should be, everybody who used that, even in the history, that is accountable. So that's 1980s. But then 1984, there was amendments. The reason is people have start dumping all this waste because they realize this circular make them liable, so they don't want to deal with the treatment. They just want to dump in the landfill and let the landfill is the responsible person. So they say, okay, that's not really helpful. Now we got to have more regulations, so that in the industry who produce the waste, they should treat it before they send it to landfill. That way, at least the volume will be minimized. So that's the biggest requirement here. It regulates the type of amend waste that you can create, how much you can recycle, how much you can save it before you dispose it. So again, these are some extra things they do. There the details, enforcement, all that factors. So um, one of the things that Resource Conservation Recovery Act did, it actually identified different types of hazardous waste. That way people know how to handle or separate different type of waste. So this is one of the important things that you have to remember is what constitutes hazardous waste. So these are the four definitions. Okay. First of all, anything that causes sick, that must be hazardous instantly. So number one, based on the property, if it is ignitable, means it can catch fire spontaneously, and spontaneously at temperature that's not normal in most of the cases. For instance, 60 degrees Celsius. If you go to the hottest place on the earth, it's around 50 degrees Celsius, not above 50. So that means they regulate after 60 degrees Celsius. That means naturally you will not have that high temperature. So that means everything that catches fire above 60 degrees Celsius by itself is ignitable. That means it's hazardous. The second one is corrosive, means it's reactive. It's related to pH. So think of bleach. Bleach pH is around 12. Um, so no, bleach or something else. I have to think of which one is. I have to look for it. One. I think it's a bleach. The reason 12.5 is because of that reason, because the household products use bleach. If you declare bleach as hazardous waste, everybody is now liable. Means now even we are dealing with hazardous in the regular uh, materials. So that's why that 12.5 came in, so that they allow that bleach to be part of the normal waste, so that it doesn't have extra regulation within the home. So anyway, if the pH is less than 2, or above 12.5, is hazardous because corrosive. The third one is reactive. Reactive means, if again, if a substance react with your skin, that is a hazardous waste. So they talk about reaction. So that's chemical reaction. So that's another little bit vague, but you'll learn a little bit more about it. And then the last one is I'm sorry, the phone call I muted was still the toxicity. Toxicity now, if it is medical waste, that's hazardous waste. It's not about, so that's all these other factors. Having said that, this really doesn't account for medical waste in that categories, because medical waste is toxic no matter what, because people assume this is toxic. So that's not categorized within one of the category, but they're handled as hazardous waste. They will just burn everything. Again, these are all tax code under D, so you don't have to remember what is that. It's just the regulatory purpose. So you might have seen uh, this kind of pictures, in any times you handle some chemicals, or you saw, if you come to UCLA, some lab has this kind of triangles, and sometimes you might see also behind a transportation truck they have those. What it means, it says what kind of chemicals they have in that transportation systems. So you see, these are the things are there, and the color indicates something else. So green means non-flammable gas, that nitrogen gas. Um, Oxygen is number two, so that means, oh, let me see, that's not the one. I have to look for what exactly it is. D. So this D has different levels, so you have to look for all those, the laws in that clause in that places. All right. So for the quiz, you should remember this. Okay. So those will be the things that define whether hazardous or not. We cover all that. So let's see if we understand what we just learned. So I'm going to start the poll. Generic questions. So you just have to choose the answers. Which of the following laws account for hazardous chemical spill occurred in the past? Give my phone to outside. I'll be back. Okay, I'll close the poll now. And poll, say results. Okay, as you see, which polls, it says that which of the following laws account for the chemical spill occur in the past. Everything occur in the past is liable, as I said. No, so that's why it's related to liability. So that's answer is B. I didn't explain this one, but let's see how many of you can guess it. But the answer 71% answer this one, 29% answer this. Okay, does the Resource Conservation and Recovery Act include liquid or gas hazardous waste? I didn't say explicitly, but think of, what is hazardous waste? Even though it's a solid waste act, what that means. Another way to say is this liquid is not hazardous waste, or this liquid will not conserve. If it is only solid, that's what will conserve. Okay, I'm going to end the poll, share the results. So 67% says this one, and 30. Some student accidentally put C and D, but that's, let's say, 31%. So yes. So the answer is yes. It does. It includes, even though it says solid waste, it doesn't mean that. It just, all it means that liquids are contained in the solid. So think of, if you have a tank, if you have a bottles full of this hazardous liquid, that's how they call solid waste definitions. Because you can put a drum full of gasoline waste, and that's hazardous waste, and they call solid waste. Doesn't mean that it doesn't account for liquid or gas. Okay, so let's see the last quiz. Which one of these is not characteristic of a D list hazardous waste? Say there are the four categories. Which one of them are not? So we launch for. I'm going to close the poll in 10 seconds. Okay, and poll, so results. If you see flammable, corrosive reactivity, as I said, less 60 degrees Celsius. If it catch fire less than 60 degrees Celsius, that's flammable. That means that's hazardous waste. Reactive corrosive is pH less than 2, greater than 12.5. So that's reactive, also hazardous waste. The only thing is water solubility, because salt is water soluble. That doesn't makes it hazardous. Okay. So the right answer is B, and 88% correctly assume that. Oh, there's another one. Which one of the following pH is not considered hazardous waste? I just said the answer before, so I just have to pick one of them. Is not hazardous, or is not corrosive. Okay, the emphasis is not. I'm not asking which is hazardous waste. I'm asking which is not. The pH scale. Normally, people write 0 to 14. Doesn't mean that there is no pH above below. The pH can be 15 to pH can be also -1, because pH is minus log H plus concentrations. So based on H plus, this value can vary. It just, most of the graphs you see 0 to 14. Okay, so I'm going to end the poll and share the results. Okay, as you see, what I wrote is anything to 12.5. So this is non-hazardous or non-core. That's what the definitions they write. Anything, this is hazard because it's too acidic, and this is also hazard. Okay, so the only thing that within this non-hazardous is, the non-corrosive is B. and 84% got it correct. A lot of times people also use 11% here. That's pretty majority, second majority. I think it could be because zero means, think of pH zero means nothing. That's not true. I don't know exactly what's the thinking process. Just think that pH zero means if the pH equal to zero, that means H plus would be 1. That means you have 1 moles per liter of protons present in that water. If it is more than 1 mole, that means I'm just going to write it here. That's how I got it. Okay, it's log scale. Um, so if it is more than 1 mole, the pH become 0 or less than 0. So it just more than 1 mole is possible, right? So that's why these are negative pH in some places. Same thing with the pH, the protons concentration decrease very low, very extreme, then it can be much higher. Okay, so all right, so we learn all kind of we learn what we learn. You can go back and see where your understanding can be improved a little bit more. Read the textbook if you have any questions. The next one is, now that you know the environmental laws and all that stuff, how to characterize and how to do the assessment if there is a pollution, because there will be always going to be pollutions. So how could one conduct site assessment? So I'm going to see if I can copy this and open in a, okay, so that's okay. It's just not enough time. So just watch this. This is an interesting lawsuit about health and environmental issues related to our communities. So that contaminated land was, for different reasons, and then when they buy the properties, how to decide who is the liable person. So these are related to things that we can all face if we are trying to own a house. This is something you have to do before even you buy a house. So that's why it's very important to have a site assessment, and it was done by professionals. So every time you buy properties, you got to go through this process so that you are not be, because you don't want to buy a property that you have to pay a lot for remediations in some time later, because you are liable if you want it. And so if you are not the owner, so at least you got to know what you are getting into. And why it is important? Because pollution is not what we just see on the surface. Pollution can be below ground, and in fact majority of the pollution is because underground pollutions. And this is just one example to show you. There are two ways the most pollutants, petroleum pollutant happens. One is because of underground storage tank. If you think of buying all this gas on gas stations, they have this underground tank. So if those tanks are compromised, most of the oils are going to mix with waters, and they will transmit into groundwater and pollute it. And there are also lots of storage facilities underground, because they don't want to, for fire hazard and for storage, they usually it's safe to store underground. So if there is any explosion or anything happen, that's not, it's just that's why a lot of times people do have underground storage tank. That means they have to really maintain them well and have to have protections. But corrosion happens, things will compromise at some point if they are not followed proper design, and then there is a pollutions. And the second one is because of use of pollutant. For instance, every dry cleaner facility, they use solvent to dry. Okay, so if you think of a dry cleaning facility, it's called dry cleaning. It doesn't mean that it doesn't have water. So if you never watch how the dry cleaning occur, just watching on one of those YouTube, you'll see that instead of using water, people use solvent so that it can dry out, and that solvent will take all the grease and stuffs out. So you're not really using any kind of water directly. So that means they have to use all these solvents, and those solvents are basically can be exposed to, so all these waste may be able to discharge into the ground. And so this is why you can see there is another pollutions. So as environmental engineers or scientists, your goal is to find out how far the pollution has traveled, where they are, so that you can install the right kind of remediation design. So first of all, you have to think of all those pollutions. So now you have to predict all that. So the pre-assessment is, first you have to go there and see what those locations, what are the different locations around it, because you are going to protect all these waterways. So first thing you have to do is, for instance, design building. What's the slope of the building where the water moves if there is a storm water or rainfall happens, and then also you will see if there is any nearby rivers. For instance, here there is a river here. So if that's the case, then you'll be able to um, hold on, let me see. The the pencil doesn't work anymore. Let me see. So I could not write today. Hmm. Okay, the pencil doesn't work, so I don't know exactly why. Somehow I could touch it and it just doesn't write. Oh, now it right. Okay. Um, so this is the river. As you see, those things are going to go through that. So you have to think of all that conceptual site model. What's the area? What's the soil type? What chemical properties there? What's the chemicals used? Because if you know if it's a volatile chemical, that means you will not expect most of them in water or soil. Must be there evaporated. And you got to look at area topography so that you know where the if there is a spill, where they are going to migrate, which side they are going to go through water. If there is a presence of surface water, because that's the exposure route, and if there are any groundwater flow directions, because for instance, if you know which direction groundwater is moving, you will be able to alert the people who are living in the downstream, or you will design your capture well in those sites. So all those other facilities utility you have to look for. So this is a pre-assessment where you just survey it area, and then once you have that plan, then you will understand where to take samples to understand the extent of pollutions. Because once you know those locations, for instance, if you know the downstream of groundwater, you are going to collect the groundwater sample in the downstream, not in the upstream, because upstream will not have any pollutant. The pollutant will know where to migrate upstream in water. So that's why it's important to know all these things and do all the lab analysis. Once you do that one, you'll know the extents of pollutions. Once you finish that one, you go to that locations, you do all this kind of survey where you mark all these utility mark everything else so that you know exactly where you want to go and do all the other analysis. So this survey site investigation required in the lab, so where you take soil samples and analyze, which is here. You can also go work with utility companies so that you know allocate, because you are going to dig soil, right? You are going to take some soil and all that. You don't want to destroy the existing utility, so you have to go there and put those markers so that you don't accidentally destroy your properties, all those things. And then also you go through geophysical monitoring. For instance, this is a radar method. You can, this basically you it measure the soil properties, so you can take that and just roll over the soils and see what kind of soil exists below it. So that way you get an idea of soil porosity, the groundwater depth, all that factors. So once you finish that one, you got to think of the extents of pollutions, and then you have to take samples from soil. You have to take samples for groundwater. You have to also take some air sampling if it is a volatile pollutants for lab analysis, just to confirm your the extent of pollutions. And those are, again, you already learned those concepts, so you just apply those concepts here. Once you have all that, you interpret the data and write reports. And these reports are very helpful because this will go to the hazardous the remediation design, remediations design. Okay, so those are the aspect you will work on. So these are all pre-assessment, and you got to learn that. So again, just write everything else what we just cover. Um, you do source assessment, which you did already. You do environmental transport and threat analysis, where you know the pollutant type. Then you will say what's the retardation factor for this soil, which you already cover it. You already know how to solve this question. So these are the steps, and then you predict the exposure, uh, which is basically saying how much pollutant remain in water that will ended up in the drinking water well. And then you'll do the health and environmental effect analysis, which is already covered in the risk assessment. So once you do all that 4 and 5 risk assessment, you do uncertainty analysis. Means you'll see what was the maximum and minimum, because it's not accurate. Everything is not finite. You have to look at the whole range. Once you do all that, do the comparison assessment, then that will help you design the remediation plan. Because remediation is all about minimizing exposure. If there is no exposure, you don't have to remediate, because there is no risk to the people. So all that factor goes into there. Again, we cover all that. We cover in the groundwater class how much pollutant will go to groundwater. Also, you cover in the surface water how much will go into surface water, the river BOD problem. What we didn't cover is how much pollutant will go through air. That will cover in the air pollution next class, or next class, next week class. And you also have some exposure risk assessment. So again, these are all covered in this class. You are just applying those concepts to solve the holistic problem. So I'll repeat the similar thing problem. I'll solve 2 questions to show that how exactly you already know this concept. So you will learn about removal processes, biodegradations. You learn about that, first order rate, and all that. You do some kind of dissolution hydrolysis. You don't know exactly those, or I didn't teach you all those exact questions, but basically it's the same equilibrium constant. You learn a lot in the following. In the CEE154, you'll learn a little bit more about those. But just know that in nature, if you spill something, these are the different processes that would change the amount of pollutant remain in the system. Once they remain in the system, then you have to think of how much they are actually moving. Okay, so the transport, the velocity, okay, velocity of contaminants. So something you already know how to calculate. So we are going to learn that again to do it. The first thing, any question before that? Okay, so let's think of this way. You go to a site and you realize that this site has some type of pollutant, and they tell you these are the list of pollutant they use. Then first of all, you have to decide, is this a bigger risk or lower risk? Is this going to be near the site, or this is going to move far away from the site? If they move far away from site, is this going to through water or through air? So all that you can determine just based on the structure of organic chemicals or the properties. We covered to some extent a little bit in the risk assessment, but this is just to reiterate again. First thing you have to think of is this water soluble, because that will determine how much of the contaminants will go through rainwater or stormwater pollutions. So the first thing I have to look for is water solubility. If the pollutant is soluble, you have a greater risk in groundwater. And how do you know that one? The very first concept is look for the carbon numbers. If you have lots of carbon in that contaminants, multiple carbon, it is hydrophobic. That means it doesn't want to stay in water. Carbon is hydrophobic, okay, um, or lipophilic. That means it stick with our fat and organs more. So just look for number of carbon. If there is more carbon there, or more number of chain, it's more likely stick with organic materials, less likely to be had soluble. So that means it's going to stay in the soil. So that means you have to treat the soil, not the groundwater, because your pollution will be less in groundwater, unless the concentration is high enough. Second thing to look for is functional group. Any functional group that cause hydrogen bond increase the solubility. And as I said, COOH, that's acidic functional group. OH, alcohol, that's another functional group. These are all amine, NH2, or CONH2, amide. So these are the different functional groups that cause hydrogen bonding. Okay, because of hydrogen bonding, they are going to be increasing water soluble. That means any contaminant that has this functional group, you can easily guess. Okay, this is going to be a groundwater problems. So that's how you can think of more. And then another is about air pollution. Is this going to be air pollutant? Well, it's based on volatility. Anything water soluble is less volatile. So that's another way. Everything that you just covered before, just think of that. If it is more water soluble, you are most likely not have evaporations into air. So how do you know what is volatile? Well, think of methane is volatile. Methane has one carbon, and so ethane is volatile because it has two carbon. So usually if the organic contaminant has less than four carbon, it's most likely volatile. Okay, even six carbon, it can be some percentage but not as much as number four. And then same thing, if it is functional group is there, it will hold on to water. So that means it's not going to evaporate. Even there is a spill in lake, it will stay in water, most of them. So these are the concept again we learn. We just apply the same concept here. The last one is how much will stick in the soil. It's based on the carbon. If you have more carbon, it's more stick with the soil. Okay, so this is just example what we learn uh, based on the structure. So this is just example I want to show you here. This is the air water or the Henry constant. If the Henry constant, so this is means Kw means concentration in air by concentration in water. Okay, so if the value is high, that means the concentration in air is more. That means it's going to be air pollution more. So just look for number. Which one is the highest here in this all these things over here? If you see, these are negative terms. So that means if this number 10 to the minus, if the lowest number is the highest value. Okay, so this is the highest value. The lowest is okay, because 1 over 10 to the 4.59. So what's the difference between them? As you see over here, the difference is this because it carries H bond. So as you see, this just having that extra functional group completely makes it a water pollutant as opposed to air pollution. Even everything else remains same. And then if you see this one, it has no functional group. That means where is going to stay more? Okay, this is water pollutant. This is air because of volatility. Okay, so this is how you can look for. So again, we cover this one to some extent. I'm just reiterating again. This is the exact same thing. I'm not going to explain. Just know that if you have more number of carbon, it will stick with the stick with the soil, more functional group. Okay, so let's again check how much you learn. If an oil spill contains the following chemical, which one of them would be present at high concentration? So I'm going to start the poll again. Um, which one of the present at higher concentration in groundwater? I'm asking which one will be in the water. The difference between them are they have same number of carbon. The only difference is they are functional group. So it's all about solubility. If it is highly soluble, that's going to be a groundwater pollution. Okay, I'm going to close the poll in 6 seconds. All right, so see other results. So 63, 80%, 80% answer this one, 20% answer this. Okay, the question was if an oil spill contained the following chemical, which one of them would present higher concentration in groundwater? So that means anything that's soluble in water is going to be a groundwater pollution. And if you know that between those two, this has OH functional group. As I wrote here, anything functional group is higher, it will be water soluble and water pollution. So that means this is the right answer. So this is correct answers. Now let's give it another try. Um, if an oil spill contained the following chemicals, which one of them would be present in higher concentrations in groundwater? So now I give you three three questions or three options. The first one is hexanol, which has 6 carbon and one OH. The second one is hexane, which has 6 carbon, no OH, no OH functional group. The third one is pentanol, which has 5 carbon and one OH group. There is no option D. So I'm asking which one is mostly water soluble. We just cover that no, between A and B, A is more soluble because it has OH. So now the answer has to be A or C, right? So you have to now think of both has OH, but their difference is carbon. So now if you have more carbon, is this going to be more soluble or less soluble? That's the question, because OH is already there. So more carbon means it is hydrophobic or hydrophilic. So think of that. Okay, so I'm going to end the poll um, in next 5 seconds. Answer anything that comes to your mind because you learn from this process. You don't have to have the right answers. Okay, end the poll. See the results. So 63% answer this one, 3% answer this, 33% answer this, and 1% D. Okay. All right. So as you see, the answer has to be between A and C because it is one of them is more soluble because it has OH. But as you see, number of carbon makes it hydrophobic. Hydrophobic means against the water. They don't like water. If something has to be in groundwater, it has to like the water. So less number of carbon means more hydrophilic. Okay. So between A and C, the C has less number of carbon. So the answer is C. All right. So now let's solve the real problem. Example problem that will be in the homework question, next homework questions. And these are again the same question that you covered before. This is a groundwater pollutions. So how long it will take for a plume to migrate or better zones and how long it will go there, you all learned in the groundwater. We are going to apply that in a more holistic way. So let's solve one questions. You already solved this one probably in the homework questions or midterms. So let's look for it. This one, a groundwater aquifer has the following properties: porosity given. So porosity is given. So that's sigma. Bulk density, that's given. It also says how much organic carbon in the soil, FOC. And it also gives you hydraulic gradients. So that's dH over dL, okay, is 0.005. And the hydraulic conductivity is given. Yeah. Um, a leakage from a faulty underground tank has caused a pollution of groundwater with toluene. Toluene, that's 8 here. So toluene, it gives the chemical structure. Okay, so that means you will be able to calculate molecular weight if it's needed. And KOC of the toluene in the aquifer material is 98 liter per kilogram. So this is KOC. Okay. And so the first question was, if the nearest drinking water well is 5 kilometers from the source area, how long in years it would take for the pollutant to reach drinking water well? So I asked you the time. Okay. So the again, I didn't give you any example question before because this is all part of the groundwater. So I ask you how long it takes for the contaminant to migrate. So I ask you T contaminants. Okay. And that must be distance by velocity of contaminants, right? So distance is 5 kilometers. That's the drinking water well, and velocity that which contaminants migrate. Well, velocity of contaminants you may not know, but you know the retardation factors. You can use that for velocity of contaminants by velocity of water is retardation factor. Okay, if you know this one, you will be able to calculate that. So this is one retardation factor is 1 plus ball density times KOC times FOC divided by porosity. So if you know here velocity of contaminant, you should be able to calculate that value. So velocity of contaminant is velocity of water divided by retardation factor. So velocity of water divided by retardation factor, and then I take the retardation factor up, which will be 1 plus rho v KOC FOC divided by porosity. So let's solve this one. D is 5 kilometers, and you have to change to 1 kilometers to meter, 1000 meter. Um, velocity of water. Well, velocity of water is related to Darcy's law, right? Well, is a Darcy's velocity divided by porosity. So Darcy's velocity is k dh over dl by porosity. So if I write this one, so you can substitute here. So let's write k value is 135 meter per day. 135 meter per day times dh over dl. So this 0.005 divided by porosity. Porosity is 0.4. So that goes to VW. And then we have to write 1 plus ball density is 1.9 gram per centimeter cube time FOC 0.2%, so that will be 0.002, and um, KOC is 98 liter per kg. So KOC is 98 liter per kg. So if you the same thing as 98 centimeter cube per gram. Okay. If you change that, because 1 kilogram is 1000 gram, 1 liter is 1000 centimeter cube. So if you divide 1000 by 1000 both sides, it becomes the same unit, gram and centimeter cube. I'm just writing 1 kg equal to 1000 gram. 1 liter is 1000 ml, and 1000 ml of water is same as 1000 centimeter cube based on the density, the volume. Um, 1 ml roughly is 1 centimeter cube at normal temperature and pressure. So that means you can write this one 98, okay, centimeter cube per gram. So that will cancel out. So this value would be whatever that number. So you know the question A. Question B is just to show that unit will cancel out. So this is meter. You'll just see that the answer will be in days. Okay, so whatever the answer is, if you write that and say this is days, you'll get the full credit. So in the final, you don't have to write all the answers. You don't have to calculate everything. If you write just that, whatever that value will be, and just substitute as days, you'll get full credit as long as you put all the right value and units. Because I don't expect you to write the, even you write the wrong answer here and put everything correct, you'll get the full credits unless TM missed it. So you got to check those. The second is if the source zone is in subsurface soil is 10-meter deep and 5-meter wide and 25 meters long, how much toluene is present in pore water if relative saturation of soil is 30%? Assume the concentration of toluene in the pore water is 25 milligram per liters, and the properties of soil is same as groundwater aquifer. Okay, so what it says that you have a subsurface. It says the size. Okay, subsurface. It's designed the size. Okay, it says 10, 5, 25. So let's say 5, 25. The 10 is the depth. Yeah. Okay, that's the subsurface. And we ask what is the um, how much gram of toluene is present. So how much toluene is present in pore water. So first of all, you have to know the pore water concentrations and then the volume of pore water. Then you multiply volume times concentration, you get the total amount. So if I write this one, the total amount of toluene should be concentration times concentration of toluene in water times volume of water. Okay. So concentration is given. So let me write this one, CW, and then I'll write what is the volume of water inside. That's basically total volume of soil times the porosity, because water doesn't stay inside the soil completely, it stays in the pore. The porosity times the volume of entire subsurface. Okay, so if you write this one, this is the volume. So let's write this one. CW is given 25 milligram per liter, 25 milligram per liter, time porosity 0.4. And then it says the volume of water is actually, it says this is the total times saturation. I'm just going to write here. The reason I wrote is I assume that entire pore is filled with water, but some of the pores are actually filled with what air in the subsurface, and that's what it says here. 30% is saturation's volume. 30% of that pore is filled. So that means only those location has volume. So let's write volume of entire soil is 525 times 10. So that will be uh, 10 times 25 times 5. This is meter cube times the percentage of that entire pore space is filled with water is a 0.3. Okay. So now everything is correct here, but if you leave it here, you will not get the full credit. The reason is there is some unit imbalance. You have to balance those units. So that means you got to say this is 25 milligram. I asked for in gram, how much in gram. So you have to change into also conversion there. So let's correct this one. 10 times 25 times 5 is how much? 25 times 5 is 125. So let me start calculating these numbers. That was
1,250.
1,250,
Yes.
which is what?
Oh, that's the 10 times 25 times 5.
Okay, I see. So 25 times 5, 4 is 25 times 4 is 100. So this will be 4. And then times 0.3. So what are the numbers? So then you have milligram per liter, right? So this will be, then you have to change 1 meter cube is 1,000. liter. That way the liter cancel out. And then you have to also change to 1000 milligram is 1 gram, because you want to express in grams. So that means these all cancel out. So whatever this number would be in gram. So let's see, meter cube cancel, liter cancel, everything cancel. So this number, whatever that will be in gram.
I'm getting 3750 grams.
3750 gram. Thank you. So that's the amount of toluene. Okay, again, the way you solve this one is you have to figure it out how much the concentration is given. You just have to know how much water is there in that subsurface. It's only 30% is saturated, means 30% of the volume in that subsurface is filled with water. And then now what is the volume of that subsurface or the pores? Yeah, that's based on total volume times the porosity. The last one, which is basically applying this redox concept. To degrade toluene in the pore water, estimated previously by biodegradations, you need to add nutrients, nitrogen, phosphorus, so that the molar ratio of carbon, nitrogen, phosphorus should become this. So basically they are talking about biodegradations. And when you biodegrade, you apply some kind of nutrient so that they can destroy it. And it says that the ratio of nitrogen or phosphorus you need to degrade by microorganism is this. For every carbon you need hundreds, every 1 mole of carbon you need 100 moles of 100 moles of carbon you need 10 moles of nitrogen and 1 moles of so it says how many moles of nitrogen phosphorus you need to inject in subsurface. So first thing you have to think is how much moles of carbon is present in water. Okay, moles of carbon as toluene. You just write here 3750. Okay, so now you have to number C, you have to calculate how much that in moles. Okay, moles of carbon. So moles of carbon is so let's say how many moles of toluene. So if I write this one in moles for toluene, you have to multiply 3750 grams. What is the molecular weight of toluene? Is C7 C7H8. So 12 times 7 plus 1 times 8. What's that number? 26. So is this 104? Can somebody confirm?
92.
Is that 92? Okay, 92. I don't know what I was thinking. Okay, 84 plus 8. Okay, you're right. So that means you have 92 gram of toluene is 1 mole of toluene. Okay, so that will be, if you divide 3750 divided by 92, that's the amount of toluene in moles. So how that number? 3750 divided by 92. 3790 divided by 92 would be 41.2 moles. Okay, so what it means that 41.2 moles amount of toluene are there and you have to degrade them. So in 41.2 moles, how many carbons is there? Number of carbon. You know that in one toluene you have 7 carbon. So number of carbon is 41.2 moles times 7, because each toluene has 7 carbon. So that will be 41.2 times 7. So that will be 288.4 moles of carbon present. So now I ask you how many moles of nitrogen you need. As you know, for every 100 moles of carbon, you need 10 moles of carbon, nitrogen. So that means nitrogen will be 1/10 of that. So that will be 28.8. Because this is 1/10. And for phosphorus is 1/100th of that. So that will be whatever that carbon is, 1/100th of that will be 2. It's going to round it up. So that means when you inject these solutions, nutrients, this is the amount of moles you are going to use. Usually that's the minimum amount. You will add a little bit more of that. So that's how you are going to have the remediation design when you have this concept. So again, as you see, these problems are very similar to what you already learned. It's just you are applying into a new concept. As long as you understand the question, you should be able to answer the same way.
Professor,
Professor.
Yes.
Oh, sorry. Someone else asked.
oh, I was just gonna ask, how did you get the nitrogen moles?
So these answers are given here. Okay, so the molar ratio of carbon to nitrogen is 100 to 10. So that means carbon to nitrogen ratio is 100 by 10.
Okay.
So that means carbon would be nitrogen times 10, or another way to write is nitrogen is carbon divided by 10. So if whatever the carbon amount divided by 10.
Thank you. I got it.
Okay.
Professor, so my question was, can you explain where you got 41.2 molar from?
So that's 3750 gram of toluene there, right? So you just have to know how many moles of toluene. So if you know the molecular weight of toluene, which is 92 gram per mole, so you divide the total amount of weight by 92, that becomes 41.2.
Okay, thank you.
If I write the right, no, my calculation sometimes is wrong. So just divide this value. You should be able to get 41.2. And then 41.2 moles you change to number of carbon. So if you know the molecular formula, which is C7, that's the 7 times. So each mole has 7 carbon, each mole of toluene. So that means you multiply this 7 because of C7H8. So this 7 comes here. Okay. All right, so that's the answer. And the last thing you want to learn in this class before is now you have polluted contaminants. Now what you have to do? You want to treat it. The way to treat it is you pump all that water. So that means you have to put this groundwater capture zone so that you can capture all the entire thing. So you already know how to design capture zone. So that concept comes here and you can put those there. And then you assume that you just learn how to do capture zone calculations. So assume that you capture entire plume, and then all the plumes are coming into the water, and then you pump them, and then you have to remove those pollutants using some kind of adsorption system. In this case, activated carbon adsorption system. You already know adsorption concept, which is basically anywhere if you know the adsorption affinity, which is concentration in solid by concentration in water, the equilibrium concentration or linear adsorption. So that's the KD, concentration in water. What it means that if the amount of concentration in water increases, more and more adsorb into the solid by adsorption and the linear adsorption. So you use that concept to remove those pollutants, and then remaining amount of things will be injected back into the groundwater. So that's how we can design this concept, how to remove pollutants. So I'm not going to solve these questions. This is you already solved it to some extent in one of the problems. So just do it yourself. Just using, I'm just going to say that this is the adsorption coefficient. Okay, this is the amount of, this is the concentration in activated carbons, and this is in water. This is in water. If you know this one, you'll be able to solve it. So what I'll do is I'll let you solve it. If you cannot solve, next class I'm going to solve it. Okay. So that's all. Just to what you learned today in this class is groundwater transport, pollutant transport. You just apply that one in this class. You also learn what kind of pollutants, how to predict their transport based on their structure. If it's more carbon, it's less volatile. If it is a less carbon, it's more volatile. And if it's more volatile, it's going to be in the air. And if it's more carbon, it's going to either stay in water or soil. So it will stay in soil if it doesn't have much functional group to stay in water. So if you have more hydrogen bonding functional group, it will dissolve more. That means it's going to stay in groundwater as much as possible. So based on that assessment, you have to design all the treatment technology. And you also learn a little bit of environmental laws. So next class, you will learn different types of remediation or waste management techniques. Again, just a brief concept because you're not going to go details. That's the CE154 is all about. Now that pollution happened, how to deal with it, how to recover some of the waste. So next class, we'll learn about more examples of treatment technologies, and that's how will be part of the homework questions in homework number 7. So that's all for this class today. Any questions before I stop recording?
I have a question. I was wondering, is wastewater treatment only feasible on like a city or county level, or does it make sense for like individual like residential units to have their own like wastewater treatment system?
It's going to be too expensive because if you think of the reason how wastewater treatment design works is it's based on the amount of carbon, right? So if you're not having really lots of waste, it's not feasible to have it in the regular household scale. And now question is, that's a good question in the sense, what if you're not connected to the entire city, right?
Right, like you're isolated and not in the city.
Yes, so how you're going to design it? So doesn't mean that they are not treating it. Yes, they are treating it, but it's a different system. So that's what they call septic tank, So basically, if you have a house, so all the waste goes to a septic tank, So they call septic tank. And there is a different kind of designs, and but the principle is biodegradations. So there are techniques, you basically put this activated carbon here so that there is nothing will go to groundwater or very limited exchange, and then you have to find a way how to remove them by biological process, anaerobic process. So there are techniques, there are engineering designs which does that. But that's not the same principle as what you learn in the municipal wastewater treatment plant. You don't have pumps and all that stuff here. Any other question? Okay, I'm going to stop recording now. You can ask more questions if you want.